Hello everyone. In this video, we will learn about a useful trick when it comes to graphing of parametric equations. So the point is that we want to go from a parametric equation or equations to an equation with only x and y. In other words, we eliminate that third variable, which we call the parameter, and then hopefully our equation in y and x will be some form of y equal to a function of x or x equal function of x, and we have a lot of tools to sketch those kind of graphs. So basically what we do, we start, remember parametric equations have two parts. One, x is given in terms of t, and the other one, y is given in terms of t. What we do here is that we solve one of these equations for t. Let's say we solve the first one and write t in terms of x. Why is it helpful? Because then we can come in and plugging that t in terms of x into this g. So t in terms of x. So the left-hand side is y. On the right-hand side, we will have a function of x. And that is, well, the world that we already know how to deal with. And then, based on that, we can figure out exactly what is our parametric equation. This can be done either for x or for y, and then you go from there. For example, let's see this one. We actually did sketch this parametric curve before just by evaluation. So here I have x equal to 2t plus 1 and y is equal to t minus 1. What I do, I choose the first one in this case. Actually, in this case, it doesn't matter which one you choose. And then I go ahead. So solve it for t. 2t is equal to x minus 1. And then t is equal to x minus 1 over 2. Now, I take this one and I plug it in here. So the result, I'll write it in the middle here. Y is equal to x minus 1 over 2 minus 1. Or in other words, we are dealing with a line. So this, note that this is an equation without t, and it's equation for a line, yes? So what we did before, just by evaluating and just guessing and finding pattern, now we can show it in details that yes, this parametric equation is an equation for a straight line. And while just it's enough to plug in x equal to 0, it will give you y is equal to negative 3 over 2. X equal to 1, then it is going to be y is equal to negative 1. So 2 points is enough for us. 0, negative 3 over 2, 0, 1, almost here, or 1, negative 1. And that is the graph that we have there. Well, in this case, you will notice that our parametric curve is the whole line. And actually, the way it starts, so just set t equal to 0, you will notice that, well, in that case, x is going to be 1, and y is going to be -1. So this is the starting point, or for t equal to 0. And now if you plug in t equal to 1, it will give you what, 3 here and 0 there. So that's the point, t equal to 1. And why is this important? Parametric curves is not just a curve, it also has a direction. So as t changes, we move in that direction. And it will cover the whole line for all values of t. Okay? Let's see another example here. So sketch the parametric curve given by this. So here I have x equals to t squared minus 2t. And y is equal to t plus 1. Well, I can try to solve first one for t, but obviously the second one is easier to solve. I can write t is equal to y minus 1, plug in there. So this is x equal to y minus 1 squared minus 2 times y minus 1. And that is y squared minus 2y plus 1 minus 2y plus 1. Yeah? Oh, actually 2y plus 2, not 1. Okay. Now that means that our equation x is equal y squared minus 4y plus 3. Well, remember that when we had y equal a quadratic in x, it was parabola, vertical parabola, either looking upward or downward. Now, this is x equals to a quadratic in terms of y. So that is going to be a horizontal parabola. And since the coefficient of y squared is positive, it's 1 actually here, that means that it's going to look to the right. Okay? So to be able to draw this parabola, I just need to find at least 2 or 3 points there. But knowing that's going to be looking to the right, I can just go ahead and you see that I can factor this. And if I set this one equal to 0, that will mean that we have 2 points at 1 and at 3. This passes through that. And then actually what will happen here is that there is a point here, which is a vertex. And we are looking for something like that. Okay. Note that this guy is the whole graph given by this, but we have to be careful because our parametric equation has a domain. She only, the parameter t is allowed to go from 0 to 4. Now, to be able to determine that part, we just evaluate some t's here. For t equal to 0, x is 0 and y is 1. So we are looking at 0, 1. So this is t equal to 0. For t equal to 4, we have x equal to 16 minus 8 is 8. And y is equal to 5. Yes, so it is going to be somewhere here. Yes. And well, that is enough. So if you want, you can put a few more points there. But that is enough to see that our parametric equation is just this piece, one piece of parabola starting from t0 to t equal to 4. And the direction, it goes in that direction. So we eliminated t, we figured out what is the general graph, but out of that, we looked at the part that the domain of t, and we fixed the part of that graph, which is for us. Okay. Let's do this other one as well. So here I have x equals to t squared plus 1, y is equal to t4 minus t squared. Here I will go with this one, t squared is equal to x minus 1. I can go ahead and solve it for that. But if you notice here, everything is written in terms of t squared. Yeah. And I can now plug in t-squared there. So y is, well, if you put square root of x minus 1 for t, it will work the same way. But here now it's x minus 1 squared minus x minus 1. And that is x squared minus 2x plus 1 minus x plus 1. Yeah? So that gives us y equals to x squared minus 2x, or actually minus 3x plus 2. Note that this factors as x minus 1, x minus 2, and that's obviously a parabola, yes, and looking upward parabola. Okay, so I can go ahead and look upward parabola like that, and x equal to 1, x equal to 2, there's somewhere in middle, it is looking upward, so it is going approximately be something like this. Okay, well, that is the whole graph of this equation, but we have restriction on our equation for values of t. So we go ahead for t equal to 0, x is 1 and y is 0. For t equal to 1, x is 2 and y is yes. So y is also 0. Yes, I was looking at this one. Okay. So that means that for t equal to 1, we are here. For t equal to 2 here. Well, if you find a few more points on t, you'll notice that our parametric curve is just that part of the parabola. Okay. So this is a trick that you can use most of the time. You can use and you can figure out the equation and then find what part of the curve is your parametric curve.